Good afternoon, doctor. My name is LIM YANN HORNG and my metric number is 231061483. And today I will be presenting for our fuzzy logic project, which is under the title Smart Coffee Strength Recommender using MATLAB FIS. The idea behind this project is simple. People drink coffee differently depending on how tired they are, how stressed they are, or how busy they are. But regular coffee machines don't adapt to these conditions. So we developed a fuzzy decision making that recommends coffee strength based on these three key inputs: coffee amount, brew time, and water temperature. And our objective was to simulate a human-like decision-making process using fuzzy logic. We implement our system using MATLAB's fuzzy logic designer, which allow us to define fuzzy sets, rules, and simulate input-output behavior easily. We focus on the Mamdani type fuzzy inference system, which is well suited for interpretable, linguistic, rule-based control. And for each input variable, we are using three triangular membership functions as shown now. And for example, our coffee amount is being divided into three groups, which is low, medium, and high, and it was ranged from 10 to 35 grams. And next will be our brew time. Our brew time is being divided into short, medium, and long, and the range is from 5 to 15 seconds. And next will be our water temperature. It is also divided into three groups, which is low, medium, and high, and is ranged from 60 to 85. And next will be our output variable, which is the strength of caffeine. The groups are divided into weak, medium, and strong, and it was ranged from 0 to 15. After we designed these membership functions and the parameters, we created a rule base that reflects how human might think when making coffee, and this will be our rules. And for example, if the coffee amount is high, the brew time is long, and the temperature is high, then the strength will be strong. This fuzzy system interprets in between values using this if-then rule. I then use 6 test sets to simulate different coffee making scenarios, and the system returned a fuzzy output that we can categorize into a weak, medium, or strong. These test sets, I run it using our MATLAB. So this will be my MATLAB codes. For this part, the test data, it is considered of the three criteria, which is the coffee amount, brew time, and the water temperature. And for this part, it classifies the output as for when it's lower than 5, it will be weak, and if in between 5 and 9, it will be medium, and if it's more than 9, it will be strong. And this will be in my output. As my output, I print out all the rules so I can have a reference, and under here will be the table of my output. And from the output, we can know when the caffeine output is about 3.8, the class will be weak, and when it's about 9.5, 10.8, or 12, it will be strong. And for medium, it will be ranged about from 5.7. This will be my data sets. This fuzzy system successfully mapped all test input into logical strength outputs. For example, a short brew with low temperature result in a weak output, while higher amounts and longer brew times led to strong caffeine levels. All the test results were displayed in MATLAB table as shown just now, along with the classifications. And in conclusion, our fuzzy logic model effectively handled imprecise brewing inputs and recommended personalized coffee strength to the users. This project demonstrates how fuzzy logic can be applied to everyday problems, and for future improvement, we may add more inputs like stress level or input mode to implement a smart IoT based coffee machine. Thank you. That's all for my presentation.